Now I'm going to apply the envelope theorem to derive another important result, Roy's identity. I'm going to apply the envelope theorem to the value function v, the indirect utility function, right, which is simply the maximum utility that I can get given P and W, so it's the utility of the optimal bundle. So if you remember the utility maximization problem, we were maximizing utility such that the bundle is in the budget set. So the Lagrangian function is simply u of x plus lambda px minus w. The partial derivative of the Lagrangian with respect to prices is equal to lambda x star. Partial derivative of the Lagrangian with respect to wealth is equal to negative lambda. Now the envelope theorem, of course, says that this is none other than partial derivative of v with respect to p, and this is none other than the partial derivative of v with respect to w. So let me name this equation number 1, equation 2. From equation 1, I can write that x star is equal to partial derivative of v with respect to p divided by lambda. Equation 2, I can write that lambda is equal to negative partial derivative of v with respect to w, and so if I combine those two results, I plug lambda into the equation above, I get x star equal to negative a ratio partial derivative v with respect to prices divided by partial derivative of v with respect to wealth. And this result is Roy's identity. Now this is actually not as mysterious as it looks. X star on the left, that's simply the Walrasian demand. I'm going to write that. Walrasian demand associated with P and W. And to understand, I guess, this result a little better, let me consider the same expression in a differential form with a discrete change in price or wealth. So the Walrasian demand function is simply equal to this ratio. There's negative sign here, which I can rewrite and you can now see that the dv drops out, and I can simply write the following. Now this expression, if you look at it, makes a lot of sense. What is this? This is a situation of a compensated price change, right? If I want to keep consuming the same bundle, remember the optimal bundle does not change, right? Then the impact on my wealth is simply the cost of that bundle times the price change. The negative sign simply indicates that there is a negative relationship between the price increase on the one hand and my impoverishment on the other. So price and wealth move in opposite directions. Now remember, again, the key point here is that all the results that are derived from the envelope theorem all rely on the exact same intuition, and the intuition is that the impact on the value function of a small change in an underlying parameter is just measured by the direct impact of the change in that parameter, disregarding any indirect impact on the optimal solution to the objective function. To the maximization problem. So here the value function is the maximum utility that can be derived, and if I want to look at the impact of a price change or a change in wealth, the original bundle that's the solution to the utility maximization problem will not change. So the change in price and the change in wealth does not affect which bundle it is that I'm consuming. That's the major intuition.